Today's lesson is, this video notes is on the different types of solutions when we are solving equations. You'll notice that I have a pencil, that I've got two different colored pens, so you should have those with you. Let's get started. There are three different types of solutions that we're going to talk about today. The first one is one solution, the second one is no solution, and the third one is infinite solutions. So let's kind of talk about what they are and what they mean. So one solution is when, in the end, when you solve an equation, you have a single variable remaining, and it is equal to, I'm going to use an equal sign there, a value. And when I'm talking about a value, I'm talking about a number. Now, what does that mean? It means that there is only one number that makes the equation true. So that's for one solution. For no solution, when you are solving it, what's going to happen is the variables will cancel out, and the left and the value on the left will not equal the value on the right. Now, what that means is that no number, and I've been using the word value for number, so no number will ever make the equation true. And what I mean by when I say make it true, I mean that it is a true statement. And you'll see this in the examples that we're going to do in a moment. The last one we're going to talk about is infinite solutions. Infinite, another word for infinite would be unlimited. So infinite solutions is similar to no solution, wherein the variables will cancel out, and our value on the left, our left value, does equal the right value. Now, what that means is that all real numbers, and you're going to hear this as you move, all real numbers, which really means any number, will make the equation true. Will make the equation true. I apologize, my writing kind of stinks right now. So let's go look at some examples. There are 6 examples here. I'm going to do 3 of them, and then I'm going to have you do the other 3 as practice. So when I look at the first example, I always want to figure out where the middle of my equation is. It's right there, the equal sign. And then I want to figure out on the left side, I see parentheses, so I know that I need to distribute. So I'm going to distribute the 3, and I'm going to go 3x, and then 3 times a negative 4 would be minus 12, is equal to 3x minus 12. And if I see this right now, I could notice, hopefully I recognize that, hey, 3x minus 12 is the same as 3x minus 12, so they're equal to each other. But I will take it one step further. I always isolate or attempt to isolate my variables first by subtracting them. 3x minus 3x cancels out, 3x minus 3x cancels out. So the variables just canceled out. And then I'm going to bring my value on the left down, negative 12 is equal to a negative 12. So which one up here talked about the variables canceling out and the left side equaling the right side? Well, that is right here, infinite solutions. So we would write down infinite solutions. Now what that means is whatever number I would have put in for x, I would put it in here and it would be a true statement. So 3x minus 12, I could put any number in there and it's always going to equal itself. Let's move on to the second example. The second example, I'm going to again identify the middle of my equation and I'm going to look, is there any distributing? No, there's no distributing. However, I notice that I have like terms over here. I have a 2y and a 3y. So 2y plus 3y is 5y and then minus 1. And that's equal to, I look over here, I have 3 different terms. I notice that I have a 2 and a 4, so those are like terms. And I'm going to put those together, and I'm going to go 5y plus 6, because 2 plus 4 is 6. And I can notice that the variables are the same and the constants are different. So I'm going to move my variables, minus 5y, minus 5y. And these cancel out and these cancel out as well. And then I get negative 1 is equal to a positive 6. Now again, my variables canceled out and the left side didn't equal the right side. So which one up here, one solution or no solutions, talks about the variables canceling out and the value on the left not equal to the value on the right? That would be our no solution. So in this one, it stands, the answer would be no solution. In the last example, again, I'm going to identify where the middle of my equation is. And then I'm going to notice that I don't have any like terms over here or here, and I don't want to distribute, can't distribute, there's no parentheses. So I'm going to isolate my variable. I'll subtract 4r from here, subtract 4r from there. And then I get r minus 4 is equal to 1. And then I want to get my r by itself, so I add 4 and add 4, and these cancel out, and I get r is equal to 5. Now in this case, there is one solution, and the solution is 5. So 5 is the only number, when we plug it back in, that would make this statement true. And that would be how you check your work. So I'll do that right here on the side. If I were to plug 5 times r, that would be 5 times 5 minus 4, and that would equal 25 minus 4 is 21. And then on the other side, 4 times 5 plus 1 would equal 21 as well. So they both equal 21. For the next 3, I'm going to slide my paper up. What I want you to do is I want you to complete these. I'll draw the line down in the middle of the equation. Looks like there's some distributing there. Draw the middle of the equation. Looks like we have to combine some like terms over here. And I'll draw the middle of my equation. And again, we got distributing here and combining like terms. And I want you to know that there is going to be one that has infinite solutions, one that has no solution, and one that has one solution. And we will go over them in class. Have a great day, and I hope this helped your understanding of one solution, no solution, and infinite solutions with regards to solvent equations. If you're still confused about this, I would absolutely watch this video back more than once, usually about 3 to 5 times. Have a great day.